welcome to join my second part of this journey. So we have covered how to create the walls, which are really dependent on your resolution and your screen ratio. Few bits I would like to point at the beginning of this video before we going forward. So one of the first things it would be to make sure that our game is always in portrait mode. If you deploy this game as it is, if a person actually rotates the screen, the calculation of what we've done for walls, it will be not applying. It will be not applying because we just rotate the screen, Of course, we can implement something like every time you change rotation, you recalculate the walls, and suddenly the side walls become, what's called wider. Because I can showcase really simple actually. If we choose landscape, you see our side walls will be here, and for some reason the top one is matching, but yeah, it makes sense. Yeah. Okay. So yeah, if you rotate sideways, it could mess our game quite a lot. You'll start seeing the platforms on the side, and etc. etc. So what we want to do is, if we go back to the game and make back to the portrait, what we want to make sure that we lock the phone rotation to be always portrait, and to achieve that, go File, Build Settings, then choose Player Settings, and under Player, under Android tab, Resolution and Presentations, Default Orientation, Auto Rotation, you just do Portrait. That's it. That's all you need to do. And now you need to build this application. It will be always the same rotation. Also, as you can see, you can have a version control here. You have product name, and you can have company names, and we will be addressing all this later on with I don't know, maybe episode I think episode 5, if I'm not mistaken. So we'll address all these settings you need to set up to be able to deploy your game on Google Play Store. Okay, so when we've done this, one point also, by the way, we have not covered yet how you can build and run on your phone. Just would like really to point one thing. If you're already testing something, you can always press develop and build and auto connect profiler. That means when you build and run, you will see all the debug log on your console messaging from your phone. So that is how you can actually to debug and see your logs coming from a phone. Of course, it's many more ways to do that one. It's some Android connector is built in Unity, but it gives hundreds of messages every frame, and it's really sometimes hard to track exactly what's happening. So your custom made messages, such as screen resolution here, and world space distances here. These messages will pop up only once when you build your and when you launch your application. So it's much easier to track in this console. To achieve that one, as I mentioned, you need to click these two buttons. But of course, we'll cover this one later on when we address building Android phone. I'm thinking to do by the end of this actually episode. Okay, one more thing. Previous lesson, I briefly touched prefabs, and in this lesson, I want to give a bit more attention to this one, because we have a prefabs here, 2 prefabs, and we'll be even creating a nested prefab. And also, previous lesson, I dragged 4 prefabs. I think it was all left ones, and I just changed name and unpacked. So a bit theory before we start. going back to our trustful paint. So anytime you in a hierarchy, let's draw some game object. Let's imagine this is a game object. It's a game object. It's empty. It could be empty game object. It could be a car. It could be player, etc., etc. In that game object, you creating something else. You adding another object, and you add another object, and maybe add one more object. Yep, and each of them objects will have some what's it called components. So the first component, the first game object could have a script. And of course, this one can have a script and this one can have a script. All these objects, they do have transform. So this has transform and this has transform and this has transform and so on and so on. So each game object has own components and so on and so on. But if we know we'll be reusing this game object, this black square, if we know that we'll be reusing it multiple times. Yep. What we want to do is actually, before we copying and paste and so on, what we need to do, we grab this game object, and what we need to do, give me a second. I'll use this time I don't know, maybe a circle. Yeah, I'll use a circle. And this is a hierarchy. Sorry if I'm definitely misspelled this one, and this is our assets. Yep. So you have assets and you have your hierarchy in a game in your scene. What you need to do is actually grab your object where you want to, if you want to create a prefab of that. So by just grabbing this object and dragging into assets, you'll make a prefab of that. Yep. And after that one, actually what you can do, you can actually delete your game object from a hierarchy. You don't need anymore to be in the scene. What you will be doing is you'll be using your prefab, which one is a copy of your what's it called in the scene. And what you will be doing is you just use that one, and you create multiple instances. So in our case, we'll be creating a lot of what's it called, platforms. Yeah. The good point is that you have two options how to edit. Well, put it this way. The key point of a prefabs is that every prefab is linked to original. And as a developer, it makes your life very easy, because if you make any change in the prefab, that will automatically update all your prefabs. No questions about it. Or of course, you can make a custom changes for each prefab if you want. Let's say you want to make something here, you make a changes. So from here you have two options. You just made the changes and it stays only with this prefab, or you can actually press a button on a corner saying apply, and if you apply the changes, it will apply change to the original prefab, and that will be applied for all other instance of the same prefab. If you want to use a prefab and destroy connection to the this network of prefabs, so what you do is you drag one of them in scene, and you right click like we done last episode. You right click and you press unpack completely, and that means it just destroy connection to the prefab. If you make changes to the original prefab, it will change only these two. And the third one, which one you unpacked, which one, in long story short, it means you just, disconnected from prefab. You destroy the link, put this way, of a prefab. That changes no more will be affecting, and vice versa. You can messing around quite a lot with this object, and it's not affecting other ones anymore. Also, I will be showing today one more thing. You can have a prefab of objects like I showed you now, but the objects blue and red could be actually be a prefabs themselves in what's it called? Yeah, like this one somewhere. So it could be prefabs themselves in our asset folder somewhere. So that means if I make a changes in this prefab, it makes changes for all that ones. Same time, if I make changes only for a blue one, it will affect here, and this, because it has the links, it will affect all that ones also. But the difference is if I have in the scene only the blue or red prefabs, in our case would be platforms, which one is affecting like walls, etc. So in this scenario, let's draw that one. Yeah, okay. In this scenario, I'm allowed, how to say, in this scenario, particularly this scenario, I'm allowed to change for red one. It affects all the this prefabs with the red one and objects which one has only red one in the scene. If this is not the case you want to do, and you make a changes, and you make some changes in this prefab, which one is contained by red one, it only affect this prefabs, but doesn't affect this one unless I particularly press a button to apply this changes. And this changes apply to original prefab, and this is links to here, and blah blah blah. It can get complicated very quick where the links goes into. But because this network you're building yourself, you kind of, you understand where you left the links, and at the same time don't be afraid to give a proper names to your game assets. In that case, it's how to say, you will not lose a track. Wall left, wall right, wall top, wall bottom. I think it's really good self-explanatory things. Okay, moving forward, exactly on this topic, I wanted to create a nested prefab system. So as we said, we have two prefabs. One is left and one is right. One really cool thing is, if I wanted to make changes for a platform left, yeah, I can, by clicking, make some changes on here. But if I need to make some changes which require some visual representation, instead of you dragging object into scene, by the way, if you can see the prefabs, we have a different color. They are blue, and we have a like box open, etc., etc. So it's a different representation. So straight away you can see it's a highlighted. It is a prefab. It means it has a link to your assets. And I have two options. I can just drag in the scene, make some changes, like I don't know, maybe I wanted to scale it up a bit and scale it down, etc. Straight away, I have this button here, like I said before, overrides, and it says on a platform in a scene, I have changes made on transform. I can revert or I can apply. Like I said, if I apply, all my linked prefabs will have this effect. Of course, I can revert, and it goes back to the original link on assets, or I can just ignore it. And next see if I drag few of them, and if I select this one and I go apply, all gets the same size. Or I can just ignore it and one of the prefabs will be the size. Additionally, if I press back this one and I override revert, it goes back to original. If I go to my, so let's say you have 5, yes, and you want to change them in one go, and you want to scale it for some certain size, but you don't know the number. You can't just enter it here. So really cool thing is you can either way double click on your prefab, or you have a small arrow in a hierarchy. Well, let's go with double click. And when you double clicking, it opens new scene where only your prefab exists, nothing else. And of course, the background is changed to blue to just showcase. Your hierarchy is also changed. You can see only now your prefab. If it's a nested prefab or prefab has a lot of things, you'll see like a full hierarchy of only that prefab. And now I can make it changes. Let's say I want to scale it like previously. If I scale a bit here, I scale like this. Okay, I'm happy like with results. You can press either way a button here, or I think escape. No, escape doesn't work. So a button go back to our hierarchy. If I go back, I can see that my changes was applied to all my prefabs. Because last lesson we right-clicked on a prefab and completely unpack completely. I done for left, right, top, and bottom platforms. This changes doesn't affect anymore because, like I said previously, I destroyed the link to prefab. Okay, let's go now back to original sizes if I can. I would hope so I can. Nope, I cannot. And what it was the size? It's a 1 and 0.2. Okay, so it's a 1 and 0.2. Really interesting, actually. I never. Okay, 0.12, and what do we have here? Overrides, revert. Yeah. So it's really interesting because maybe if you go, so Control Z doesn't really have worked on a prefab changes I made. It's a possibility I need to go inside in the prefab and then Control Z what I made inside. I'm not sure exactly how it works. You can experiment yourself around, but as you saw, just Control Z was not really reverting my changes on the prefab. Also, if you want, you can make multiple instances of prefabs. So I can, if I like this prefab, but I want to make a version of that one, you can Control D, and you have a copy of that one. Or if you you have one if you have a prefab already on a scene, you can drag that one in assets and ask you, is it original prefab? So it's make an original prefab, which one will not have any linkages to the previous this one, or it's a prefab variant, and you can actually have like semi linkages between them, if it makes sense. I don't really have a use cases where and especially of this scope of the game, you need to have a prefab variations. But in the larger games, like AAA games, I believe it's a lot of use cases where you have this different prefab linkages types, put it this way. Okay. Yes. So to put this in use case, we have a prefab of left, and we definitely have a prefab for right. So we have two prefabs. I wanted to create a new one where we call it a platform. And this platform, I would like to have left, right. Of course, I would like the platform to be at 0, 0, 0. Then I would like to be platform left to be 0, 0. And the platform right, I would like it also to be 0 and 0. That makes sense. And additionally, I would like to create another empty object well, we call it score. Yes, let's call it score. And the score should have a box collider. 2D box collider, yes. So something like this. Your game object should look like this. We have a left, we have a right, and we have a score box collider and this platform. So now I have like, this is a game object I would like to repeat multiple times. Oh yeah, also, let's add the platform as a script, and I cannot do for a very simple reason. A platform must be inherit from mono behavior. Yeah. Okay. So platform must be inherit from mono behavior. Save. And now I'm allowed to by selecting platform, I'm allowed to drag platform as a game object. Okay. Okay. We'll address this one later on. But talking from platform prefabs perspective, now we have a platform, and I know I'll need to reuse this multiple times. I don't know how many times yet. I don't know exactly how many times, but I know it will be reused many times. Yeah. So what I need to do is very simple. I just open a prefab folder, and I just drag this platform into assets folder called prefabs. Now I have a prefab which contains platform game object with script platform. It contains two prefabs of a platform left and platform right, and we have a trigger box for score. So we'll be using this trigger box to detect when the ball falls through the hole. Okay. Happy days here so far. And you can see, by the way, the platform changed color and is showing up that this is now a prefab. And of course, at the same time, I don't need any more of this to see on the screen, because our manager, platform manager, will be actually how to explain. Our platform manager will be actually linked to this prefab from asset folder, and will be initiating them as many as we need. Of course, we need to change this one to portrait. Yes. Okay. Yeah. Okay. Save. Okay. So far, so good. So today we will build our platform class. We extend that one, and by the end of the video, or by this actually section, we should be able to generate platforms, which is scrolling up with physics, and we'll make sure that the ball is not falling through it, and of course the falling trigger and the bouncing trick. Okay, so it's a lot of what to do. So let's jump in. So we need one more public game object. So we have a left and right platforms, and of course we need a score trigger. Score trigger. Okay, we will need 3 game objects to work per platform. If you're making your game and each platform will have how to explain it? Your platform will have some unique stuff. I don't know, like explosions or some effects, etc. So they should come here. And again, it really depends your game logic. One of the things I want to showcase is a different score system. So we need public int hits. We want to reward player with a different score value depending how many times he hit the same level. Long story short, if no hits equal 3 points. So player managed, and he was really lucky to get through the platform that one level without touching any platform. One hit is equal 2 points. 2 points and 2 or more hits equal 1 point. Yeah. So very basic calculation of the scores, which one brings to the game, you know, how to say, variations and reaching the same speed of the game. Either way could be very low in points or you could be very high in points. So it's really pushing player to hit, you know, the holes as soon as they can, scoring as high as they can before the game is, you know, increases speed, and that speed becomes so enormous that, you know, you can't keep up anymore and you have very low points. Okay. Of course, we need a public boolean scored. So we'll definitely want to track if this platform already gave points, if this platform already added the points to the player. And the reason is because if your ball bounces through the hole, hits a next platform and bounces back up and goes back the same hole in, you don't want to keep adding scores just because the ball is already past the hole, for some reason gets back through the hole up and goes again back to that same hole. You just only scoring one time. So we have a boolean, which one is scored, it will be false, and after you scored, it's a true, and no more points for this platform. Okay, so because it's a mono behavior, we'll be not using this one anymore. So please delete that one. Of course, it should give you an error because we have some dependencies here. No, actually we don't. Okay, we have not done last lesson. Okay. Instead of that one, because it's a mono behavior, we want to type void start and hit enter. It should give you a default class start, and I know it's default because the color of start is in blue. If I create another function like void start up, you can see it's a different color. So this is a default one, which one will be executed by Unity engine. What do we want to do when we start the game? We really simple. We want to say that the hits is equal 0. There's no hits happened, and the scored is equal false. So we have not scored anything. Okay. In update, we want a public void and lowercase update. And it's a really interesting. Okay, if your compiler corrected you to make a uppercase update, please delete and make it lowercase. And the reason is really simple, because we will be executing this update ourselves from our physics, from our you know, how to say, we'll be executing this function from a different script, which will be aligning all the physics. Otherwise, we could possibly run to the problems, and the problems is such as you have this what's it called, a platform, and the platform will be moving, and the platform is moving like, let's say, in a simple update, and update is happening. Let's say your phone is running really great, and you're running like, I don't know, 120 FPS, yeah, because you have 120 hertz screen, etc. Yep. So happy days, your platform will be moving up. Will be changing position 120 times per second. In another hand, your ball is falling down, not because of a script, which one will match your platform speed, but is falling down because of physics engine. and because of physics engine, he's falling down in different ratio, and I think it's a 0.1 second refresh rate, which one makes about 10 FPS. I'll double check this one, but we have a dedicated session only on physics improvement and performance. But the thing is, because this 0.1s doesn't match with 120 FPS, etc. Let's assume these numbers. It's really high risk that in a high speed, the ball is actually appearing in different locations and could potentially just go through your platform without hitting and no bouncing effect. It just goes through the object. And then mainly because the platform movement is executed by script and normal behavior, and our ball falling down is executed in a physics engine, and they are on the same. They are not synced, put it this way. Because of this reason, what we want to do is lowercase update for our platform, and we'll be executing this function, align up with physics. And it's really easy to do, actually. It will be just a fixed update, which one is one of the shortest path to do it. But still, I wanted to call that fixed update in one location where we execute all our physics, including the falling ball, and then we do a checks. So what I'm trying to do, what I'm trying to say, we could just go with fix update like this, and that will very synced with our physics engine. But again, I want to do everything there in fix update in one location, and I'm assuming this will be inside in the platform manager. Okay, so update. In update, we want to do transform, and you can do many things. If you're doing something like this, transform position is equal to left transform. Oh, okay. Yeah, no, this one. So transform position plus new vector 3. I don't know. It's 0. Do we have a speed? Oh yeah, in update we need a float speed. Yeah, that's better. That's another reason why we want to execute everything in one location, because every time we call this update from platform manager, will pass a speed it must to go, and that will be linkages for all platforms. If you do fix update in each platforms separate, they lose this linkages with one script identifying the speed. So in this case, we do speed and this. So this is one of a beginner's level. This is it has multiple problems actually. So let's start one at a time. First of all, changing position like this, it's not advisable in Unity. Changing position, it's literally teleporting. It will teleport from here. It will teleport. It is positions plus up. Well, y direction up. Which one is up? Yeah, and that changing position is literally teleporting between these 2 points from A to B point. Nothing happens. No collisions. No nothing. So very strongly not advisable this one. Instead of transform dot position, we use translate. And to translate, you need to pass a vector 3. Okay. So we just we just sorted out one of the problems. So now when we're translating from A to B, it's a smooth translation, and it's something happening between these 2 points. It's it's executed like etc. like physics collision system etc. Another problem is well, first of all, we know when we translate, you don't need your current position anymore. So we need to delete this one. So it's translate. It means when you're changing position, you're giving a new position relative where you are. So your position is your position plus adjustments. When you have a translate, it is your position and you're just giving your, what's it called, adjustments. So if it's up, you're just passing up. You don't need to tell it it's up from where you are, if it makes sense. And in a position is a bit different, unless you're using some local and other tricks. But again, for translate, you don't need to tell it. It is, you don't need to say transform dot position plus this one. So you don't need to say where you are plus up and apply to this one. No, it's already applying. So you don't need to identify where you are. Okay, so and you translate. Another problem is speed, and this speed will be translating our transform each time we call it. In our case, it is a bit tricky because not every computer or device runs on the same frame per second. So if your computer or your phone has better performance, you'll be seeing the same game running much faster because you keep adding you keep translating object much faster time, much more often than another phone which runs maybe 20 on the maybe it's running only 20 FPS, very old iPhone 4, maybe not even 4S, etc. And to make sure your translation is same no matter what performance you have, and this is really key. Actually, it's really applicable. This technique is applicable across all platforms and PC games. What you need to do is actually you need to your speed multiply by time dot delta time, and this is a fraction. This is a fraction of your how long the last frame took to render. So time dot delta time could be possible is equal, like, I don't know, 0.015 second, etc. And another computer maybe renders in maybe less FPS and it will be rendering maybe 2.5 seconds. It's only 4 FPS, etc. So you, by multiplying this fraction of a second, you always receive the mathematically what you do. If you say your speed is equal 5, no matter what happened, by multiplying by time delta time, the 5 units will be moved per second. Yes. If you're running only, I'll give you an example. If you're running 4 FPS per second, so 5 times 0.25 and multiply 4 FPS, you'll get 5. Let's say you're running more and it's 10 FPS, yeah, so 0.1 second, and multiply of 10 FPS, you end up with 5. Doesn't matter what you get, multiplying by time delta time, and because it's how many frames it happens per second, you always end up with your 5. Let's say you run 20 FPS, so your render time is 0 this, and it is a 20 FPS. So this is a delta. This is delta time, and you always finish with 5. Okay, I think it took a bit too long to explain a very simple thing. Not very simple thing, but a few guys maybe got a bit bored now. Okay, let's get to the fun part. This is really simple. Just update and we get past the speed, and it looks straightforward. Okay. Yeah. Some of you maybe want to write this one more advanced way. I prefer to do similar. What's it called? Similar way, but what I do is vector free dot up, and vector free dot up multiply by speed, and multiply by time, delta time. And both of them do the same. It just vector 3.up is actually 0, 1, 0, and what that means is, because we're multiplying by speed, whatever speed you have multiplied by 0, it's equal 0. Multiply by 1, it's become, let's say our speed is 5, so it's become 5, and 5 times 0, it's 0. When we multiply by time delta time, and again 0 times is 0, 0 times is 0, and here multiply by time delta time, it's the same as speed multiplied by time delta time. So what it does is just simplify it. It's more readable actually, especially if you familiarize with vector dot up, down, left, right, etc., etc. Okay, let's delete this one also. We need to get a height. So our platform manager will be asking each platform how high you are, and platform must return the height. So it's a public float get height, and because our both platforms is same height, it's the same height left and right, so we can just return return left dot transform dot position dot y. We don't need to return or tested left against right, because we're not even moving them. What we're doing, we're moving a parent of a game object, this. So we're not moving left and right separate. We're not doing left dot transform, because that will be just moving left side. What we're doing is moving transform dot translate, which one is a parent of both, or no, not both, but all these three objects. And in that case, when we're moving this transform, it will move all these objects all together. So when we're getting height, we're just returning left side, and we can safely assume that right side is in the same height. Okay. Additionally, we need a public also, public void reset platform. So reset platform is when it goes out of your screen or at the beginning of the game, we just literally setting in its height. In the same time, we reset its hits number and score condition. So we actually can start from here. So hits is equal to 0, and scored is false. Yeah. Okay. So after resetting, it resets these two variables. To reset successfully our platform, we need few variables, parameters. We need a float to know how height we want to reset this platform. Also, we need to know float a gap size. So because every time we reset, we want to give a different gap size. This gap size will be controlled and assigned by our platform manager. Okay, and of course we need to know a float position. Okay, this position, maybe I need to give a better name, but this position, left position, put this way. Okay, left position. And why we need this? So back to our trustful paint. So if this is our screen, and if you know your gap, yeah, you don't know where the gap is. Okay, so what you need to do is, when you know your gap, you also need to know how far the left side is. So you need to know this point. Yeah, this point. And then after we knowing this left position, we're knowing this gap size, doing very simple math calculation, we can calculate how far right should be. So we can just find this one. We don't need to ask anymore the right, because just, we know the width, we know the gap size, we know the left, we know, and most important, we need to know this point. Okay. Okay, a left position. And I think it's the three variables we need to make this one. So very simple. This transform with all the objects with the trigger left and right, its position is equal to new vector 3, and it will be 0 point height, yeah, and comma 0. That's too many zeros. Okay, and can you see that it's not translate? As I said before, if we translate from above the screen and we translate our platform below the screen, that translation can cause some triggers, some collisions, or some anomalies within scene. What we want to do is, when it's above screen, we want to teleport below the screen. And of course, this height will be like -10 maybe, or something below the screen. Which one, again, it should be very adaptive, because not everyone has the same screen ratio, resolution, etc., etc. Okay, so height. Okay. Next one, we want a left dot transform dot position to be a new vector 3, and we want to just do a left position. Let's float, and I think it should be height, yeah, and it should be 0. Okay, so the same height, blah blah blah. Then we want to do right. Okay, transform dot position should be equal to new vector 3, and this is where the fun part happens. This is where the fun part starts. Is it? Yeah, it should be gap minus plus. Okay, yeah, it should be just left position. Left position plus gap size, comma height, comma 0. I'm double checking this one. So this is a left position. The right one is the left position plus gap. So we're leaving a gap between left and right. Same heights. Everything is in the same heights and the same z. Okay. Makes sense. Okay. And that's it. Our reset platform is done. Oh yeah, one more thing. We need set void set up trigger, and the reasons of that is our trigger at the moment. If we drag one of them, keep changing this one. If you drag one of what's it called, let's drag one of this. Yeah. If you go in and you select your score, you can see it's like a square in the middle, and we want to be actually what we're seeking is on a scale X should be same scale as the screen. So maybe 5.6, I think it is somewhere like this, yeah. 5.6, so it will be, or 5.8, I can't remember exactly. 5.7, 6, 5. Just, yeah. I'll leave it this one. So same size as the screen, but what I want to do, the height should be a half of the platform's, no, not the half, same size of a platform, so 0.2, but I want it to be lowered by half of that one. So 0.2 multiplied by minus 0.5. Yeah, so something like this. And if we take our left platform like this, and we just, you know, what's it called, expand it, etc., and we expand it this one, yeah, and when we select score, so score will be, can we just remove ball? Yeah, so score will be just below our, if a ball hits and goes in, it actually triggers, and it will be halfway through the hole. And it is below because, you know, you don't want it to make it, how say, you don't want it to make it the same level, because if a ball goes up and down, it accidentally can trigger, depending how physics will happen. If 1 pixel of a ball goes inside in this platform to bounce off, it could trigger the box. So that's why you want to go below, and I choose to go a half size of a platform. I don't want it to make it narrower. I could make narrower. I could make it like 0.1, you know. But one of the reasons is I don't want to go narrow because I want it to make solid length to make sure physics doesn't skip and actually triggers. I don't see any problems, you know, to do that. Okay, Control Z, 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 Z. Okay, yeah. And why I Control Z or not set this numbers? Because again, this trigger box should to adapt depending your screen resolution. And to achieve that one, we need to do this via code. Okay, so it's really simple actually. It's a score trigger dot transform dot local scale. It will be equal to, okay, we need a float. We need a float from platform manager saying screen width with something like this. Okay, so new vector 3, and we want to go with the screen width. Then we want to go with the height should be the same as left dot transform local scale, not x. I want a thickness, so y. And here we just always do 1. Very simple. So it's the screen width and this one. And now we want to do score trigger dot transform dot local position, not position but local position, is equal to new vector 3, and we want to do in x it should be 0, comma, and we want to do left transform local scale dot y divided by 2, comma 0. Oh, divided by 2f, by the way. And yeah, like I showed you previously. Like I showed you previously, we want to move by the half of thickness. So it's exactly half platform below than the left and right. So we don't accidentally trigger it. And local position 0, 0, 0. Okay, yeah. Is anything? Oh yeah, add the score. So we wanted to trigger this one, public void add score. And here I want to introduce you to a really new, maybe we have not touched this one in my tutorials, but it is return. So if if scored is equal true, so that means we already scored, and we just asking to score again. What we do is return. And when you're using return in any function, if this is read by a compiler, nothing below will be executed. So I can write here, I can write anything. I can write here anything. I can do debugs and so on, so on, so on, so on. If scored is equal true, it's return, and nothing below this line, nothing below line 38 in this function, only in this function, will be executed. Something else below, it will be executed. You know, if I have another what's it called, avoid another function. Jesus Christ, what's happened? Yeah. So you have another function. So if the score is true, this will be hit return. Anything here skipped, but this function will be already. So it's only will be skipped in this, what's it called? I can't remember. Scope, I think it's called. Only in the scope. Okay, and you can see minuses. So you can definitely see where is the scope, and the scope is different. If you hang it, if you hover the mouse, you can see the scope size. Nice. Okay, and this is a crucial because we don't want to do anything if it's already scored. One more advice. If this is a boolean, you don't need to say is it equal true or false. You just say if scored, so it's mean if this is true, execute this one. Else scored is equal true. So if you already scored, please return, don't execute anything else. If it's not scored, please make it scored, execute your stuff, and if the second time it will be, what's it called, called out, you don't do this one. Actually, I will do this. I'll do more readable, more maybe self-explaining. If it's scored, return, don't execute anything below. Don't execute these lines. Okay? If it's not scored, execute all the lines and mark it down as scored. So this platform will be not adding scores anymore. To do this one is really simple. If hits is equal to 0, we want to do very simple now. Debug.log. We want to say 3 points. Else, well, let's copy paste. Copy paste, paste. Else, but no ifs. Okay, one of the good points to learn also is always to think about if conditions. You don't want to do if, and if, because you by this looking, you know that only one of them could be true. It could be hits equals 0, so you just score without even touching any platform. It could be that you touch only once and you want to add 2 points, and or doesn't matter how many times you hit, it's more than 1, so 2, 3, 4, whatever, it's only 1 point. And because it's only one of these conditions could be true, you're always doing if else, if. And this is really sometimes performance related stuff. If this is a true, what is the point to test this ones? Physically, it can't be hits equal 0 and at the same time it could be equal to 1. It's either way, it's equal 1 or equal 0, etc. We can write here also 2 or more, but I just left else. Yeah, one of them. This checks is very simple and straightforward, so it should not take any performance if you even just leave ifs. But it's really good practice, because if we're talking about bigger game, this checks here could be very performance consuming checks. And if you executed one, you don't want to execute the second one, third one, or many of them. So what you want to do is, okay, if this is a true, that's it, finish, and you don't need to execute other ones. Okay, and after that, we have add scores. Done. Set. Oh yeah, public here. Awesome. Okay. So our platform script has all functionalities we need to carry on. Let's adjust our platform script to make this happen.
Slowly kisses passing by the river.
So next step, what we need to do is actually to identify and or put this defined a falling trigger, and it's in a float. And I think what we will be doing, a trick we will be using it. Of course, we can use multiple tricks, but one of the tricks I'll be introducing to you guys is actually we'll be using a line below a screen. So I'm trying to get like 25% ish of the screen. So if we have a half, we divide by, we have we have these lines, and if we're taking a camera min y, we're getting this lowercase, and divided by half, we get 25% of the screen. And the trick will be very simple. Let's get a ball. Let's get a ball in red color, and a trick is really simple. If then the ball is keep bouncing around, it does have velocity. And if a ball is falling down, what we want to do when it hits this area, we want to remove velocity downwards. So in a game, from a game perspective, the ball falling down, it stops here. But when it hits this location, we want to start speeding up all the platforms coming from below a screen. And it looks like it falling down, and the platforms at the same time coming, slow, a normal speed. It hits screen position, not platform. It's like it's invisible line. When it reaches this invisible line, it stops, and all the platforms starts speed very quick. It looks like it's falling through platforms, so it speed ups. And it's two tricks or key points we need to do. If a ball falling down in angle, it must from a game perspective, it must stop like this, but continues move sideways. So because you think this way, if it's falling down through the holes and all the platforms moving very slow, it's keep falling through the holes and it hits this location. Or platforms start speed up, so it looks like it's continues falling, but it's not falling anymore from a screen perspective. But what it must do is keep move in X. So visually, it looks really great. From mathematic perspective, very simple. The ball falls down, it reaches a certain location within screen, all velocity downwards is removed. Only downwards. So that means if it's coming from angle, it's not moving down anymore, but it continues travel sideways. And because how physics works also, and the moment that the moment it hits a new platform, which one comes from below a screen, we need to add the force to simulate the bounce. Because we remove the velocity, and by removing velocity, when the new platform comes, it takes the ball outside of this line. What it does, it's actually okay. That gone somewhere. Okay, can I get my ball back? No, I can't. So what we need to do is actually to simulate that bouncing back. Okay, so very simple, but it's very simple when you know it's this approach, and like I said, it's multiple approaches you can do. I just want to double check we're recording. Yes, we are recording. So yeah, let's dive in the code, and let's see how it looks from perspective. So as I said, we want to hit a falling trigger to be our camera min dot y. So it gives us a half screen. We want to do multiply by 0.2 actually, and that gives us a 20% of the half. So it's a 10% of full screen. Okay, it's not 25%. Sorry, it's 10% of a screen. Okay, you can play with this one. It could be different area. Don't forget that the camera min dot y. It's only the half a screen. It's only half screen. So when you do some math, you can even put some objects there to make sure you're in the right position. Okay. When we want to update, we want to do a very simple thing. We want to check falling. So we want to void check falling. Okay. And a check falling, it should be very straightforward actually. Do we have a ball? Yes, we do have a ball. Okay. So if ball dot transform dot position a dot y is less than camera min dot y minus falling trigger. What do we need to do? Okay, so falling trigger, paint. I like paint. Very simple to explain something. This is our screen, yes. So we just so camera min. If we do this, yeah. So this is a camera max dot y, and it's a min dot y. And yeah, we got camera min dot y. Then we done a math. How much is 10%? So we know how much is 10% of a screen. So falling trigger. But we don't know exactly where this 10% must be applied. We never said it. So 10% must be applied by camera min dot y. So this point minus 10%. So minus 10%. So our point is here. That's why we have this camera min minus falling trigger. Okay, and what we do is very simple. It's just simple saying that falling speed becomes 5. You can play with these numbers, and if the ball is above, then we're saying else falling speed is equal a 0. Okay, that's falling speed. This is addition to your normal speed. So float. So it's not affecting your real speed, because your real speed is keep changing because of your level you are. Maybe you have some power ups, or maybe you have some different levels, etc. So your normal speed it's a different story. This is your falling speed when your ball is reaching end of the screen, and you need to give more platforms. Because if your platform is moving too slow, or maybe the player is very lucky and he's hitting constantly the holes without any touches, And yeah, it's reaching the end of the screen. You want to give more platforms for a player. Okay, that's it. That's falling speeds. Now generate walls. We have this ones. Okay. Generate screen location. Oh, get screen location. Okay. Check falling. Oh yeah, check falling. Let's call it every frame. So we want to check this while the ball is falling down. Okay. Very simple. Only what we're missing is between generate walls. We need to generate void generate platforms. Make sense? Something like this. Yeah. So generate platforms should be called after we generate walls. So generate platforms. Yes, please. Okay. So in generate platforms, we need to define two things. We need to define what is the start point of platforms and platform endpoints. In our case, we want to platforms start somewhere below a screen, and we want to start somewhere above. We want to end above, above screen. And when we end above the screen, what we do, we just try and teleport a platform below screen again and change its randomization. So changing gap location, changing gap size, etc., etc. If you have some unique power-ups, you maybe have some ratio or percentage or chance. Put this way, you have some maybe chance to spawn some coin, etc., etc. So it's variabilities you can do. Okay. So in general platforms, we need to define this one. So I would like to do our platform start to be our camera min.y. I would like to actually multiply by 2. Yeah, I would like to be twice. So if I have this 50% of screen, I would like to go. So this distance is a camera min.y, yeah? I would like to go the same distance below screen. It doesn't hurt if you generate more. Why not? You can even go even more if you're not sure or you don't trust of some resolutions and you want to make sure you have generated a lot of platforms. Just be mindful, because if your platform is a bit unique and has a lot of active animations or something like this, you don't want to generate too many of them, like, I don't know, 10 times of your screen, etc. It doesn't make any sense. Also, don't forget, we're not destroying them. We create them at the beginning, at the start of the game, and we keep moving them from endpoint to start point and keep changing its properties. Put this way. Okay, so platform end, it should be camera mix.y. Yes, correct. I like this AI suggesting what I need to type in. Now, number of platforms. Yeah, number of platforms. Very simple. We know this. What's it called? Let's minimize a bit. We know start. This is a start point. Yes, we know start point. And we know end. Yeah. Now, because we know the gap, we want to create between platforms. Yes. It's very simple. We need to know what is the distance between start and end. Yeah. And just divide it, how many gaps we can make it. So that's mean we can make it, we can find how many equal platforms, equally distant from each other, we can make it. And to do that one is really simple. It's just number of platforms is equal platform start. Platform start is negative number because it's below 0. So what we need to do, put in a bracket from beginning. So we need to put in the brackets and multiply by -1. So let's make it positive. It always will be negative. It's below the center. And okay, what else? So yep, we need to add our platform end. Okay, like I said, we need to find this distance first. So we have this is a what's it called, platform start. Which one is negative? We just multiply. We need to add platform end. Yeah, and we then, by doing this, adding them together, we get this distance. Okay. Now we need to divide. Now, when we added them together, we need to bracket them and divide by distance. Okay. And silicon. Now, this number is a float. And you can cast a float. So the casting works like this. You have a variable. Yeah, this is a variable float. This is a variable. Which one is a type of float? And I gave a name variable float. You know, we can give it a name X. Yeah, or A. Let's give it A. Yeah, and if this A is a float, but we want to make it integer. That's really simple. What we need to do is before the variable, we just need to type int. And now the system takes a variable A and will cast into integer. If you have I don't know, A plus B, and you want to make this result into integer, because in this case, you're just casting only A, not result A plus B. So what you need to do, you just put A plus B in the brackets and result will be casted in int. It could be an error sometimes. If this, let's say, is something else, something like string, which one has some letters, and you're trying to cast an integer, is the compiler says like, what the hell? I can't change letter F to integer, etc. So, but in our case, it's a float. Okay, so it's very simple. We need to put in a bracket all that sum and everything, and this result must be cast into integer. So whatever we're doing here, please convert in integer. Converting float to integer, most of the times you will lose any decimal point. That's all what's happening. Okay. Getting that. Okay, so now we just find how many platforms we need to do. So with this information, we can do for I as all as I equal I is less than number of platforms, I plus plus. Okay. And what we're going to do is just really simple, like create a line. Okay, we don't have a create line function yet. Okay, so we here to create a new platform. Okay, to do that one, we need this function. So let's make it one. Okay, it's a void create new platform. Create new platform. Okay. Yeah, and we just need a float height. Yeah, we need the platform. Yeah, height and create new platform, and we need a height. Yes. Okay. Yeah. Makes sense. So now when we're creating new platform, what do we need to do? We need to know the gap. Yeah. So gap size. Gap size is equal to random dot range. Is gap size is oh, okay. It's local. Okay. So float. Let's have a video. Oh, float, I said, yeah. So float gap size will be a random range, and we know that it should be min gap max gap. So the gap size where the ball needs to get through will be between minimum and maximum. This between minimum and maximum could be adjustable by level, by your by the room player is playing, or what you think is the best for a player. I think I made quite large gaps. We'll check later with the numbers. I'll share these numbers. What I think is quite a kind of acceptable as a beginner level. And of course, you can make, even if you make it just larger numbers and you just want to make very big at the beginning and very fast is getting narrow and narrow and narrow. It's up to you. Okay. Now we need to create a game object, which one we'll call a platform object. Oh, okay. One few things. Previously, we have left platform prefab and the right platform prefab. Please, now let's change this one into platform prefab. It's no more left and right as a separate object. It's a platform prefab which one holds left, right, and score trigger, and it's a platform parent. Okay, yeah. So platform object will be equal to what we want to. Oh yeah, we want to create it. Yeah, instantiate game object. And we want to pass our platform prefab. Then we want to define that as a platform parent dot transform. Okay, so in instantiate, it's, long story short, it creates a game object in the scene. Because we're passing our platform prefab, it creates a copy of that prefab. So we can create as many as we want these copies in the scene. A second variable, platform parent.transform, is a variable defining where in a hierarchy to put this game object. So we don't want to place this platform prefab just randomly in a hierarchy with no parent, nothing. We want to be a bit, how to say, tied up. So platform create a new game object from copying from platform prefab, which one is in our asset prefabs folder, and please put this new game object you created in hierarchy under platform parent game object. So if you look in our this one, we have a platforms game object. So all new platforms we create will be under this game object. So when you extend it, we will see all the platforms you created, and we can just close this parent, and everything will be there. Okay. What else we need to do? Yeah, we need to do a lot actually. We created. Oh yeah, and why we doing equal to platform obj? Because we want to have a reference to this game object. If you don't write like this, if you just created the game, you just created this game object, but you lost your references to it. If the next line I say, oh, do something with this game object, you cannot, because that object is created, but you don't have any link or knowledge or references to it. By doing this way, I know that this new object I just created temporarily will be called a platform object. Now I can do a magic with that one. I can say platform game object transform position. Yeah, it's equal new vector. Actually, not like this. It should be 0 height. Yeah. So now we created. Now I can put in this position, and I can say platform, platform, blah, blah, blah. it's similar, but not add component. It's a get. Okay, so now I need to get this platform game object in our one, guys. Yep. So in our prefab, it has a script called platform. So what I need to do is to platform to get this object. So platform object, get component, platform script, and we can check platform prefab has a platform script. Okay, and platform. Yeah, platform dot reset platform. And to do reset, we need to pass height. We need to pass the gap size. Yes, the gap size. We know gap size. Then we need to pass a okay. Yeah, what else we need to pass? Oh, we need to location. So we need to random dot range, but it's not range min gap. So it is a camera min dot x, and the camera max dot x minus gap size. Okay, and this second. So what it does, it is very simple actually. Go back to this 100%. No more Control Z's. So what I need to do is I need to get a random location of a gap. So if we have this gap can be from camera.x up to camera max.x minus gap. So if we're looking at this corner, if we're looking at this corner, so it will be camera max.x at this point minus gap, and we get this point. Otherwise, it just camera min.x, if it makes sense. I hope I'll explain this one quite a lot. So we know the height. This is a gap size. Which one is a random between man and gap sum? So then we know the gap size. This gives you random position or in the screen where that gap must be. And we don't want to, we don't want a gap to be outside of the screen. We don't want it to be gap not in the screen at all. So it's because our gap is always treated by left side. So it's either way, it could be a camera min.x, like I said, this wall. So that red square rectangle representing our gap could be somewhere here as a minimum, or it could be maximum camera max.x minus gap size. And again, it is camera max.x is here minus gap size. It's exactly what it is now, this point. And this random range allows this red square, well, rectangle, to be somewhere in the screen. Okay, so that's how we reset. And of course, we need to platform. We need to set up a trigger, and the setup trigger we need just give our width of the camera. So camera max.x multiplied by 2, because this gives only half screen, and silicon. And oh yeah, last thing, we have a list of platforms. So all the platforms we created at this create new platform, we want to keep a track of them. So we have a platform list. We created last lesson. In the last video, we created a new list. And in this list, we want to add this. platform. Yeah. So now we create this platform. We move this platform. We get that platform's script. We call few functions from that script. And then we, and then lastly, we add that platform in the list. So when we do some activities, I believe this will be next video because this is getting a really long one. We'll do some tricks, and because we have references in our list, we can loop them through the list and check everything what we need. So yeah, create platform. Let's paste this in here. Create platform, and because we have I, it's very easy actually to what we can do. It is a thinking. Yeah, well, let's do from let's do below. No, let's do about. Yeah, let's do about one unit below the screen. So we need a height. So camera min dot y plus 1. So this camera dot min plus 1 is camera min dot y is here. Plus 1 would be somewhere here. Yeah, maybe we start with a ball here and all the platforms is around here. Happy days. And what we want to do, here. Oh yeah, and now each platform. So we need to put in the brackets this one. So camera plus 1, and we want to subtract another brackets, and we want to subtract distance multiplied by I. So I will be 0, I will be 1, I will be 2, I will be 3, etc., and so on and so on. So what it will be doing is, because we know the distance, it's multiplied by this, and we keep subtracting. So the first platform will be here, the second platform will be here, and the third one will be here, and all of them will be distancing the same distance. Yeah. So I will be 0, it's here. I will be 1, I will be 2, I'll be 3, and so on. And this will be do as many as we need because we know the number of platforms already. Okay, and is there anything else left to do? Create a new line. We just done it. And generate platform. Yep, we've done it. Check falling. Looks great. Fixed update. Yay, we're not moving anything yet. Yes, that's so. Let's do somewhere here. So we want to avoid fixed update. Yeah. And we do for each this time. For each is really similar like for, but it does, need I anything. So for platform, okay, platform in platforms. And it is similar for int, but for that one you need a integer I, and you do conditions, etc., etc. For each is similar, but instead of you looping with numbers, what it does, it's takes every member from this list, and this list is the platforms type of platform. So it takes all the members. We keep adding members actually here. We keep adding the platforms add. And we keep, doing so. Let's assume we have 10 members. We have 10 members, which one is equally 10 platforms. So what for each does, it takes one member from that list at every time, and it will become a platform. So I say, let's say debug.log, platform. It prints platform.name. Yeah. So it prints in the debug.log the name, and it takes the first member, prints a name. Done. It takes a second member, it becomes a platform. It prints its different name. and so on and so on. So each time it loops, every time it takes one member from the list, it will become a platform. So everywhere in your script will be inserted as a platform name and executes the script. Then this platform becomes a follow-up member and execute again. Again, platform becomes another member and so on and so on. Similar with like but to do that one, I need to do platforms and square brackets and put I and put name. If platform forms, sorry, yeah. So similar like this, but each time I want to access it, I need to access platforms.i.name. In this case, platform becomes a member of platforms. Jesus Christ, that sounds really confusing when I said this loud. But yeah, you definitely if this is something really difficult to understand and you get your head around, you're more than welcome to use for with integer I loop, or you can actually to have a look for more advanced and longer video as just explaining C# for each. Because I don't want to get this video too long and getting very deep dive in for each and how it works and differences between I++ and ++I, etc. Okay, so platform dot we want to do update, and yes, we want to pass our speed plus falling speed. As I mentioned before, that is a speed that you could decrease or increase depending power-ups or your level. But this is a separate speed you want to add on the top because your ball is reaching end of the screen. Okay. Then we want to say if platform dot get height is greater greater or equal to platform end. So we know that the platform reached that point where we are safely can teleport below. So we want to do a float gap size again. Gap size is equal to random dot range and we want to say a min gap comma max gap. So before we teleporting this platform, we want to do random range again to generate a new size gap, and the same will be here. So it's a platform dot reset platform, and we need to say the height will be platform start point. We know this height, we define it. Then we need a gap size. We just randomly find it. And the last, we need a left position. And the left position will be, again, random dot range. And it should be between a camera, again, camera min dot x or camera max dot x minus gap size. And again, it's very related to the same topic where we want to move this red to move this red square, which one represents a red rectangle, which represents our gap within screen to the left and right, some randomly. Okay, and Salicoma. Is this enough? Less or more, it's enough to see a lot of things. Of course, we don't have a lot of what's it called? We don't have ability to move our ball yet. We don't have a lot of physics within our engine. So let's make sure all this is done before even we going next. So in our platform, let's double click a prefab. And our platform script doesn't have some bits. So we want to drag our platform left. We want to drag platform right, and we want to drag our score trigger. Okay, that's done. We can simply press back. In the manager, our platform manager don't have a ball reference, so let's drag that one. It don't have a platform prefab. Yes, we need to drag this platform prefab from assets. Platform parent, you want to drag a game object from hierarchy where we want to create and save our platforms under. So under this game object. Min gap, max gap. Let's have a look in one of my notes where I created previously. So min gap 1, max gap 2, distance 2, and speed 1. I found quite acceptable numbers. Again, you can play with this one. Don't forget the screen width is a 5. So 1 to 2, and 2 is close to like 1/3 of the screen ish. I think it's a bit more than 1/3. Yeah, you get idea. Okay, what else are we missing? Of course, we can just hit start and see what errors it brings. What I forgot. Okay, what we forgot is to scale it. Okay, platforms and prefabs is not scaled enough. Okay. Yeah. Setup, reset, getting height, setup trigger, add a score. What do we want to do this? I'm not sure what I want to do because reset platform is it's keep asking. It's keep asking quite a lot. We want to do this one only once, and let's do separate, like public void and set up platform length. Yeah. And what we want to do is we want to know the screen float, screen width. Yeah. So one of the things is we want to know how much if I drag one of them, yeah, how much of this I want to scale to make sure it is covering a whole screen. Well, it's not like this, because it's like this. If you turn on, you have a gap here, you have a gap here. It doesn't make any sense. So what we want to do is we want to make sure that it is covering all screen, but it's never happens like all screen because you still have to have a gap. So safely, we can assume if I make this a length of the screen, which one is 5.8, I believe, or 4.6. If I make this length of this width of the screen, I can safely assume that it will never, this edge will be never seen, because we always will have some gap. And let's say gap is 0. Even if the gap is 0, that should perfectly to fill the screen. Okay, and to do that, we just really do simple, because we know our screen width. We can do left dot transform dot local scale is equal to screen width, and the same right dot transform dot local scale is equal to screen width. Oh, okay, yeah, you can't do this one. Oh, geez, Christ, it's a bit more difficult. It's a new vector 3, and x will be same as it was. So left dot transform dot position. No. Local scale dot x. So local scale is equal new vector and local scale dot x. That means that wherever x was, we're not changing. The y, vice versa. we only changing x, comma, y should be stays the same, and we know z it's always 1 in 2D games. Okay. Yeah. Same applies to right. So new vector 3 screen width right dot transform dot local scale dot y comma 1 brackets semicolon. Okay, so local scale becomes an x. We're changing y. Leave it the same as it was, and z1. Okay. And we need to call the same location where we're calling this one. So it is in the platform manager. We create new platform. When we create a new platform, we're saying platform platform dot setup platform length, and we have the same. It's a camera max dot x multiplied by 2. Okay, let's have a look. Okay, so let's hit the trigger. Okay, nice. We can see some problems with collisions. Does console has an error? No, console doesn't have an error. But as I said, if you now open the parent of platforms, you'll see all the platforms, and it has a clone, and a clone indicates that Vea was created by script. So we have this all platforms. They going below screen. They are much below screen because our endpoint is here. So when we go up and we keep rotating, you want to make sure it's there. But I don't really like where the ball is hanging, and I'm trying to find a reason of that. And if we go platform here is a box collider. Happy days. Box collider there. Score. And the score is above, not below. So it's two things. First of all, let's stop. In the project, when let's double click on our prefab. So score is a trigger. Please tick the box. That means that this collider, 2D collider, box collider, it doesn't stop the ball. It becomes only a trigger. So we only trigger some event, but it does not affect for physics, like bouncing off or stopping on it. It doesn't affect anymore. It's just a trigger box which one goes through. That's one problem. Second problem, it is above, not below. So when we have a platforms set up a trigger, I wanted to do negative left transform local dot y divided by 2. Save. So it should be below a platform, not above. Okay, let's save our scene, play game, and yeah. Okay, it was interesting at the first one. Let's have a look what's happened afterwards. Yeah. Okay. As we don't have any control of the ball at given time, it's a bit what's it called? Hard to say something. And yes, this is one of the problems also, because how to say, we don't have anything. The ball is already gone actually, but we can see now how the platform works. We had one unit above, we have one unit below, and yeah, all the gaps you can see they are appearing within screen, and they are random sizes, and all that could be adjusted. And if we go back here, this is going very fast because our ball just fall off. And this is one of the examples you saw that the ball is not hitting every this one. And I think easy fix for that one is the ball must be it's a continuous, yes. It's dynamic. Yeah. Okay. Yeah. We address this in the follow-up video where we will speak exactly about physics and to make sure our translation and updates of physics. You see that? Yep. Okay. It's nothing to do with. Okay, it's nothing to do with translation. I do apologize. It's something to do with platform right. Let's go in the yes, platform right does not have a 2D box collider. Simple as that. And double check if we go in our nested. Yes. Okay. So yeah, it's a right. Double click on the right platform. Not platform prefab. Platform right prefab. And add the box collider. Double check if both they do have. Yes, they both do have. And the platform prefab is another one. Yeah, do have this one. And let's go back. Let's hit one more time. I was a bit curious what's happened actually. Yeah. Our velocity and the speed is not finished yet. So when falling is triggering speed, but we don't have, as I mentioned, we're not addressing velocity. We're not stopping its falling. So the ball looks like he hangs in the air. It looks very great, but it's not completed yet. So stay tuned. Please subscribe if you're new to the channel. And yeah, comments how to improve these lessons or feedback are welcome. And yeah, stay safe in these days and have a great time. See ya.
I know gold is not enough.